All right, so there are a bunch of different parent functions. The constant one is a horizontal line. This linear one is the straight line. These should all be ones you saw. The absolute value is two lines that come together at the point. The quadratic is the u. The absolute value is the v. Then you got the square root. You got the cubic, the cube root. And that's kind of where it's like, don't know. Like, that's kind of where you're probably stopping, like, for right now. Did you see anything else besides these in your, did any of these other ones come up?
No.
All right. So what I generally start with here is the quadratic, the square, and try to like give you all the possibilities. So y equals x squared, and then all the different transformations. So the first one is you can go left or right. And you do that. I'll write an example here. Y equals x minus 2 squared. This is 2 to the right. And there's a lot of ways to remember this, but what most students do is they remember that if it's minus, it's right, and if it's positive, it's left. There is a better way, but it's not worth trying to convince you of that at the moment. This is 2 to the left. So if it's inside and it's negative, it's right. If it's inside and it's positive, it's to the left.
Okay.
So the next thing we can talk about is up or down. So there's up and down. So if I give you y equals x squared, and then I give you y equals x squared plus 2, this is 2 up.
Okay.
And notice that it's like outside the parent function. So then you've got y equals x squared minus 2, and that's 2 down.
Okay.
All right, so if this was clear, I'll give you a first example here, and I'm going to help, but we have to eventually do some where we were going to scale. So x minus 1 squared plus 2. There are two transformations here. The first one is left or right, and then up or down.
Okay, so it is 1 right, and 2 up.
2 up. Very good. Let's do another example. This one has one transformation.
Oh gosh. Minus 4, so 4 down.
4 down, very good. So it doesn't have to just have one or the other or both. It can just have, I mean, it could just be one, like it is here. Okay, so let's do another example here. Y equals x plus 2 squared minus 3. This has two transformations. Let's see if you can get them both here.
Two left, 3 down.
Very good. If you're looking at your notes, that's totally okay. The goal is to get you to where you can do this without your notes and just visually see it and know that, hey, this is all good.
Okay, yeah.
Okay, so we're gonna kind of switch examples here, but I need you to see that the same thing applies. So let's say I tell you that y equals the square root of x minus 4 plus 3. This also has two transformations. The inside one here is left or right, And this one out here is up or down.
Four right,
Okay,
three up.
very good. Now I'm pretty sure your class will do something weird, and I'm going to give you this weirdness. They're going to give you y equals x minus 2. Okay. They're not going to give you what I consider to be kind of the ones that are best for like explaining transformations. They're going to give you a line.
Okay.
So and when is your diagnostic again?
Friday.
Friday. Okay. So here's what I'm going to do. I'm going to go into Desmos. I'm going to graph this, and I'm going to come back and snip it in because we need a nice clean line here to talk about. And then you're going to, I hope you're up for this. You're going to want to definitely ask your instructor the question I'm about to ask you, because it's terribly unclear the way that they teach this. So I want you to give them what they want for the right answer.
Okay.
So there are two things that could be true here. This point right here and this point right here, they are 2 apart. You see that?
Yeah.
2 units apart. This point and this point, they are also 2 apart. Do you see that? So is this a shift down, or is this a shift to the right? Now I have my answer, which is not important. What is important is what your instructor wants. So I would probably ask your instructor this question. I would say, is this a shift right? Or is this a shift down? I think they'll be very impressed if you ask them that, because it's that you need to know so that you can do the test right. Because I think they end up asking something about lines on this one. I'm trying to vaguely remember. I mean, they do the same tests every year. So if you know someone, you could even find that out as well.
Okay.
So now let's look at something slightly different. Let's say I tell you that y equals x squared. Okay. And then the next one we look at is y equals 1/2 x squared and y equals 2x squared. So now we're putting a number in front. Do you see that number and that number? So if the number is less than 1, like this, it widens the graph. And there's some variation on language here. This one, since it's greater than 1, it shrinks the graph. But the language they use tends to be vertical stretch by a factor of, and it's whatever that number is. So it'd be a vertical stretch by a factor of 1/2 or a factor of 2.
Okay.
Okay. So let me incorporate that into an example here, and we're going to work through this together. Y equals 3x plus 2 squared minus 4. This one has 3 transformations. The first one's inside here. It's left 2 units. This one is the last one. That's down 4. This 3 is a vertical stretch by a factor of 3.
Okay.
So let me give you one to try now on your own. Let's say the example is y equals 2x minus 3 squared plus 5. Give me the 3 transformations. The order does matter. The order absolutely does matter. We can talk about how you figure that out, but use the same order as the previous problem there, please.
Okay, so the first one is right 2,
It is not right 2, it's right.
right 3. Oops.
Yes. And it's that simple to make that kind of just, you put the wrong number in, or you're looking at that too. It's just so easy to do. What's the last one?
Up 5.
5.
And then the second one is vertical stretch by a factor of 2.
Yes. Now you may also want to ask your instructor, like, hey, how much of this do I have to write out? Like, do I have to write all this out? I can't answer that for you because it's really up to what they want for this.
Yeah.
Okay, so now let's just say, here's another example. Y equals 4 square root x minus 7 plus 12. This one also has 3 transformations. Go ahead and give those to me whenever you're ready on that one.
Okay, so the first one is right 7.
Okay, I agree.
The third one is up 12.
Good.
And the second one is vertical stretch of 4 or by 4.
Excellent. Excellent. Okay. So now I'm going to give you a line. I actually think they use lines in this. So let's say it's y, it's 1/2 x plus 2. This has 2 transformations. The first one is it's a vertical stretch by 1/2. The second one is it's up 2.
Mhm.
Now I'm going to write the same thing over here, but just in a slightly different format. This one has 2 transformations as well. It's left 4. And it's a vertical stretch of 1/2. If you distribute this 1/2 in, do you agree that you get back to the original function? The original over
Mhm.
here? So my question to you is, or this is because I'm pretty sure this is how it comes up on the test. At least that's how it's been in the past. Like, I would want to know, ask my instructor, like, which one do you want, Mr. Instructor? Because they're very different, even though
Yeah.
they're the same graph. And it's because lines, he or she might say it doesn't matter. It's because if you move a line this way, it's the same as moving it down. And I don't know. That's why I want you to ask, find this out, so you know.
Okay.
That covers kind of everything that I think is reasonable to ask you about for transformations, and still get to some of the other topics tonight.
Okay.
So if you're still not, if you want more, we can try and do it at the end. But let me move to systems and see if we can find some questions that are more challenging than the ones we did last time. So, all right. Okay, so I found some here. That's not what I want. Okay, I think I've got it. All right, here we go. All right, so systems of equations. The first one we'll look at here is number 8. 4x minus 4y equals 20. 4x minus 2y equals 16. How would you solve this? Do you recall?
You add, wait, is it add or subtract them together?
If you're comfortable subtracting, that's great. a lot of students aren't, so they end up having to multiply everything by a negative, but it's 4x minus 4x, that's 0. Minus
Mhm.
4y minus a minus 2y. So that becomes positive, so it becomes minus 2y. And then it's 20 minus 16 equals 4.
Okay.
And then you divide both sides by -2. So y equals -2. Then you can use either equation to find x. So I'll use the top one. 4x minus 4 times -2 equals 20. So you got 4x plus 8 equals 20. Subtract 8. And you get x equals 3.
Okay.
So if you understood that, let me have you try one like it. This was over here, number 7. Go ahead and give that a try. Probably need a minute or two to get that done, but go ahead and try that one on your own, please.
Okay. X equals 5. And then y is -5.
Hey, I'm sorry there. Did you follow that?
Yeah, I did.
I was muted here unnecessarily, so I apologize. Now we'll go back and use the first equation. So 4x minus 3 times 1 equals 5. 4x minus 3 equals 5. 4x equals 8, so x equals 2.
Okay.
I'd still like you to get one of these without my assistance. Let me give you one here. This one, believe it or not, works out nicely. Let's try one more of these before we move on to a different kind of case of. So again, you're going to subtract because you're going to cancel out the y's. And I know the numbers look big on the right, but they do turn into nice numbers also. Should get something like minus 3x plus 0 equals negative 47 minus a minus 68 becomes positive 68, so you get 21. You should get x equals minus 7.
Yeah.
And then we'll go to that top equation, 5 times negative 7 plus 2y equals minus 47. We'll just solve the way we've done many times before. And it looks like y equals negative 6.
Okay.
All right, now we do need to do some questions where you end up multiplying both equations, or you multiply one of the equations by a value. So I got one here for us to look at. I think this is the, I think this is still pretty straightforward because usually it's pretty clear like which variable to eliminate. You can actually get a choice here. You can either eliminate x or y depending on what you multiply the first equation by. Because you could multiply by minus 2 to get that to minus 8x, or you can multiply this by minus 3. And it's your choice. So what do you want to multiply the first equation by? It basically depends on which variable do you like to eliminate. Do you want to multiply by minus 2 to get minus 8x and cancel with that, or minus 3 to get minus 12y to cancel with that?
Minus 3.
Minus 3. So I'm going to write the result below. Minus 12x minus 12y equals 36. Now I know we were subtracting before, but generally it's best to add, especially when they're already opposite in sign. So this is minus 4x plus 0 equals 40. Divide by negative 4, divide by negative 4. So x equals negative 10.
Okay.
Like you to go back and see which, so get the value of y using either equation or the other.
Y equals 7.
And I'm just going to check it here. 784. Which equation did you use to find y? The first one or the bottom one?
The bottom one.
Bottom one. So 8 times negative 10 plus 12y equals 4. So this is minus 80 equals, is that so? Okay, so we get minus 80 plus 12y equals 4. Add 80 to both sides. 12y equals 84, so y equals 7. Excellent. Okay. All right, now the next example, when you look at these, you have to decide which variable you're going to eliminate. And see how these are already opposite in sign, and one multiplies can get to the other. That's kind of your like indicator. Like you could multiply the first equation by minus 3y to cancel the y's, but when they're already opposite in sign, why not just multiply by 2 to get minus 8x plus 2y equals 14.
Okay.
So now you can add them together. The x's cancel, the y's remain. 5y equals minus 5. Y equals minus 1.
Okay.
So go ahead and find the x value for me, and then we'll move to one more question like this before moving on to another type of systems.
X equals -2.
Equals -2. All right, very good. All right, so one more to try on your own. This is kind of like your exit card. Like you to try this one and just give me the final answer when you're all done. This one.
Okay. Okay, I got 5 for both X and Y.
Maybe it's better to eliminate Y here. Sorry, you didn't hear me there for the last 30 seconds. So you eliminate Y here because it's opposite in sign, but you can't just like multiply to get 5 or 5 to get 3. So you end up having to multiply both equations. So you get 5 here, and you multiply by 3 here.
Okay.
So in that first one, it's 30x plus 15y equals -15. Now they do get a little bit big, but it's 3 times 9. So that's 27x minus 15y equals 129. Yours won't get this big, but this is the worksheet I had to pull from.
Okay.
So this becomes 57x equals 114. And believe it or not, x just equals 2.
Okay.
Sometimes students like these better because they have to do something to both, and there's not like a trick or like a shortcut. You just have to do this long drawn out thing. So 6 times 2 plus 3y equals -3. So you get 12 plus 3y equals -3. Subtract 12 from both sides. 3y equals -15. So y equals -5.
Okay.
All right, so let me have you try. Let me have you try this next one and see if you can do this on your own. If you can, we kind of are done with systems because there's only so many types that you need to be able to solve.
Okay.
So you're going to try and eliminate y kind of the same way you did for the first one. All right, if you haven't done this, you're going to multiply the first equation by 3 and the second equation by 2.
Yeah.
And keep going here. So you're going to add them up. You get 24x equals 72, and then x equals 3.
And then y equals 5.
Y equals 5. So that would be 18 minus that. Yep. Y equals 5. Very good. Okay. So for me, I think as much as I can sort of do in this lesson for systems, I think we've covered it. I'd like to move to Radian measure.
Okay.
All right. So the next topic is Radian measure. So 360 degrees equals 2 pi radians. So one revolution of the circle, the unit circle, is, and the multiple choice options are 360 degrees, 2 pi radians, or both. So if you go all the way around the unit circle, you've done both.
Mm-hmm.
So this is what leads to this conversion of, like, if I give you the degrees and I want it in radians, you multiply by pi over 180. So an example here, let's say I give you 90 degrees and you multiply by pi over 180. This equals 90 over 180 pi, which reduces to 1/2 pi, or pi over 2.
Okay.
But you probably won't get that. You probably get something like 215 degrees and you multiply by pi over 180. And that gives you 215 over 180 pi. Well, this you have to reduce. And if you don't have a calculator, that's where I guess the trouble could be.
Um, 43 over 36.
Say that again.
43 over 36.
Oh, I gave you the wrong value. I'm sorry. 225. I should have given you the known ones. These work out nicely. Sorry. This is 5 pi over 4. Sorry, I gave you the wrong one. Yeah. Okay. Now, in the same way, we just went forwards. You can go backwards. I can give you radians, and you can be asked to convert to degrees. So to do this, you multiply by 180 over pi. So let's say someone tells you, oh, it's 4 pi radians. You're like, great, I'm going to multiply by 180 over pi. The pi's cancel. 4 times 180 is 720, and then you add in a degree symbol.
Okay.
Now, what if the instructor tells you, I want 11 pi over 6 radians into degrees? You're going to multiply by 180 over pi. The pi's cancel. 180 over 6 cancels into 30. And so you get 11 times 30, which is 330 degrees.
Okay.
So there's only so many of these examples I can give you. I'm either giving you degrees and you're going to radians, like we just said, or you're in radians and you're going to degrees. Did you get any other examples in class, or like, was it like maybe circumference or area problems or anything else?
On the diagnostic, there was a picture of like a circle, and then it was like how many radians are in the circle or something like that. I don't remember the question exactly, but it was something like that.
I do remember seeing that at some point. So they ask you, here's a circle, and they say, how many radians? And if you go all the way around, it's 360 degrees times
Mhm.
pi over 180, because that's your conversion, which is 2 pi radians. Okay.
Okay.
But they also do this. They ask you how many degrees in 1 radian. So to do that, how do you go from radians to degrees? You multiply by 180 over pi. So 1 radian, like you're used to seeing a pi there, you multiply by 180 over pi. And if you have a calculator, this is approximately 60 something degrees. So that's format long. About 57, this is approximately 57.3 degrees.
Okay.
Does that sound familiar at all, or is that something that didn't come up?
It sounds familiar, just a little
Okay.
bit.
All right. So the last topic, we've got a few minutes left here on parent functions. Do you recall what you were asked, what you had to do with parent functions?
Um, let's see. Okay, so it was f of x to gx with transformations.
Do you have an example?
Um, it was kind of just like start with parent functions and then
Okay.
create a vertical reflection.
Okay. Okay. Yeah, I can see. Okay. So there is a transformation we did not talk about. So we'll just go that direction. Y equals x squared. Y equals minus x squared. So x squared is U-shaped like this. Minus
Mhm.
x squared is also U-shaped, but it goes down like this.
Okay.
Okay, so this negative is a flip over the x-axis.
Hmm.
So let's add that into an example that we're going to do here. So let's say I give you y equals -4 absolute value x minus 3 plus 2. There are now 1, 2, 3, 4 transformations. And the order is based on, think of how you would evaluate this if I gave you a value of x. Like let's say x was 10. What would be the first thing you would do here?
If x was 10,
Yeah, you would subtract. You would subtract 3.
yeah,
So that's your first transformation. What is minus 3? It's 3 to the right.
yeah.
Then you would multiply by 4. And since 4 is on the outside, it's a vertical stretch by a factor of 4. Then you have to deal with this negative. This negative is a flip over x-axis. Then you would deal with this 2. That's 2 up.
Okay.
So let's try another example here. And the parent function doesn't matter. So let's say it's y equals -3/5 x plus 1 cubed minus 7. The parent function doesn't matter. You look at it the same way. There's 1, 2, 3, 4 transformations here. See if you can come up with those. It's just like the last problem. They're just different numbers, different parent function.
Okay, so it is left 1,
Left 1, good.
down 7.
That's got to come at the end.
Oh, okay. Vertical stretch by 3/5.
Then you deal with the negative.
And then flip over x-axis.
Yes. And
And
then
then down
minus
7.
Very good. Okay. So this is the hardest thing to do, but this is probably going to be on there. Let's assume your parent function is x squared, and I tell you that it's left 2, and then it's up 4. And you have to figure out what this becomes. So here's the left 2. It's x plus 2 squared.
Okay.
And then the up 4 would be x plus 2 squared plus 4. So you can almost just guess. You can guess this and then see if it does these things or not.
Okay.
So let's try another one here. Let's say I tell you that your parent function is y equals the square root of x, and we want it to go right 5 and down 3. So right 5 is like square root x minus 5, because the part inside here is what tells you whether it goes left or right.
Yeah.
The down 3 is outside here. That's minus 3. See how it's on the outside?
Yeah.
Okay. All right, let's try one more here. Let's say your parent function is x cubed. We want to go left 3, up 4. So see if you can do that on your own, please.
Okay.
X plus 3 cubed is the left. Did you get that?
Yes.
And then the up 4 is x plus 3 cubed plus 4.
Yeah, that's what I got.
Okay, great. So you might see something more sophisticated than that. I'll just remind you that really the most important thing is probably to ask your instructor about these line questions, whether they're right or down, and even use these examples. And like, you can even say, look, I did these examples, and like, one is right, one is down, and then here's the other one. One's a vertical stretch and up, one's left, and then a vertical stretch. If you're comfortable doing that, I think you can do it, and might shock the teacher, so to speak. But that is it for today. Thanks again for scheduling, and I'll send you the notes and the screen recording out shortly, and I'll see you next time.
Okay. Thank you.
You're welcome. Bye now.
Bye.